Okay, so in 9.6, number 15, I would like to plot the square root of 4i in the complex plane using the polar form. Ooh, wait a second, what's the polar form?
Radians and thetas.
Yeah, Paulians is something about radii and thetas or something, right? Okay, so
Radii and theta.
I want to look at that thing and think to myself, that's the square root of
2 times 2 times.
something plus something i's, right? Okay, so with me on that?
Why not times instead of cross?
Fair question.
Okay, anyway.
I think I'm gonna need that anyway.
Okay.
So yeah, let me gloss that for just a second.
Okay.
You'll see it.
Cool.
So how many somethings without i's you got on them in the 4i up there?
What was that?
1,
What do you got without an I on it up here?
1.
0.
Nothing.
Nothing, right? So there's nothing, and then there's 4 i's, right?
Oh, I see what's happening here.
You guys with that?
Does it matter which, like where you put the 4 or the 0?
But like 4i plus 0.
Yeah, 4's definitely got to go with the i's.
Okay.
And what I'm aiming at here, right, the like polar form, I'm really kind of aiming at r's and thetas, right? And I'm kind of recalling with r's and thetas, there's this e to the I theta is cosine theta plus I sine theta,
Totally.
right? So now I'm looking over here and be like, okay, so cosine of theta seems like it's 0.
Okay.
So when's the cosine 0?
I don't know, pi.
Pi over 2?
Oh.
So like this guy, I'm looking at cosine of pi over 2 maybe. Doesn't have to be pi over 2, but could be. Over here, I got a 4. I don't know what the hell to do with that 4.
Cosine was 0.
You see that? Cosine's
Pi
negative
over
1.
2, not 2 pi.
I don't know what to do with the 4.
That's interesting.
So I'm just going to think there's a 4.
I saw.
And then where do you get a, oh, there's kind of like a 1 here, right?
Yeah.
So at pi over 2 is sine 1. Yeah.
What?
At pi over 2, right?
Oh, pi over 2 is sine 1.
So you went up here on the unit circle. So unit circle, you went up to pi over 2. Is the vertical bit there 1?
Yeah.
Yeah.
Yep, cool. So I got 4 times sine of pi over 2 times I guess. Oh, look. That bit kind of match this bit and that bit. So that's kind of causing me to think that in here at least theta is pi over 2.
Okay. So
Okay, so I'm thinking there's an e to the I pi over 2 in there. You guys see that? Where did this 4 come from?
it's like a
Isn't
vertical
Yeah, it's like a radial.
radial growth.
It's like a radial stretch rather than a vertical one.
Yeah, that makes more sense.
You see that? So I was thinking r's and thetas, right? But I just wrote down a theta part.
Yeah.
You guys see that? So if I wanted to add the r part in there, I'd add that in as, well, r times the e to the I theta is r cosine theta plus r I sine theta. And then I'd be like, oh, hey, dude, r's 4, man.
Okay.
Right? So I think I found out that r is 4 and theta is pi over 2.
Alright.
So it'd be like, okay, so the original thing that I started with, right, so my square root of 4i, looks like I can rewrite it as the square root of 4e to the I times pi over 2. That's cool, that?
Interesting.
Okay.
So the keynote is just remembering 0 plus the 4i, that first bit.
Yeah, basically the keynote is remembering that polar form in complex number land looks like this. That's the polar form of the complex number. Okay, so when I'm square rooting, What's the square root of 4?
2.
And then I have the square root of e to the I pi over 2, right?
Yeah.
Oh.
Pi over 2 is like a square root.
Pi over 2 is like what?
Pi over 2 reminds me of a square root. 'Cause
Yeah,
1
there's-
over 2 is like a square root. And anytime, so the denominator will denote the fact that it's a
The
square root,
bottom.
but then pi is inside of the function.
Yeah, there's some like weirdness, right?
Yeah.
I'm looking at the square root and I'm thinking, okay, square root's a 1/2 power, right?
Yeah.
Okay, so maybe I'll just rewrite it that way. So I got 2 times e to the I pi over 2.
Times 1/2.
Oh, and you multiply the powers, right?
So it's going to be pi over 4.
Oh, so that's 2 e to the I times pi over 4.
Cool.
So I square rooted the radius, and then what happened to the angle?
Whoa. Square
What
root.
happened to the radius?
And it also was.
So the radius was 4,
Cut in half.
right?
Yeah.
So I square rooted
Cut
the
it-
radius,
Cut in half.
and then I cut the angle in half.
Oh,
for
so
square
you just
rooting.
went down and then over
Wow.
that way.
So my 4i, right, was just 4 units up here. Like this point here is 4i. Now the square root of 4i is a radius of 2 and an angle of pi over 4. So
So-
angle of pi over 4 looks like this.
And then a radius.
And then a radius of 2 puts me out here someplace.
Well, so what's the slope of that?
So that's the square root of 4i. Got it.
What's the slope of that?
That's crazy.
What's the slope of that?
What?
Yeah, it's a 45-degree angle, right?
So it's a.
That's the line y equals x,
Oh, so it's just
right?
a 1 over.
Yeah.
Drawn in the
Big
complex
angle.
plane. So that's where the real part and the imaginary part are the same thing.
Oh, I see. So what if it wasn't a pi over 4? What if it was like something weird, like
Yeah,
pi over 3?
if it was like pi over 3, you'd like think about pi, right? That's this angle here, and then you'd split it into 3 pieces. Or you might notice that pi over 3 is like 60 degrees.
Yeah.
You guys cool with this?
Yeah.
And if you wanted to get a value of kind of the usual form, right? So there's a real part and imaginary part. Just calculate twice the cosine of pi over 4. So what's the cosine of pi over 4?
Over square root 2.
1 over the square root of 2.
Uh,
And then there'd be a plus 2i, and then what's the sine of?
1 over square root 2.
Of the same thing. You see that? So that's
Whoa.
crappy
2
handwriting
plus
from that
2i.
side. Square root of 2 plus the square root of 2 i's.
Or.
So this is the answer written in algebraic form. This is the answer written in polar form, and this is the answer drawn on a picture. Cool. So I think they asked for drawn on a picture. I think they said plot in complex plane using polar form. So I used polar form to plot this. You guys cool with that? That help answer your question, Mark?
Yes.
This is a cool trick to know. We used that in differential equations class a few times.